factor positions, you can have two solutions of workspace 1. Okay, so there will be two solutions in workspace 1, one solution in workspace 1 limit. Limit means this final boundary, there will be only one solution. Okay, and there will be two solutions, theta 1 and theta 2 in this workspace, an infinite solution in this WS2, which is equal to 0. Now you can see here, if there are 3 degree of freedom system, you can see here 3, L1 equal to L2 equal to L3, then what will happen is maximum will be 3L, minimum will be L1 if you fold here, and L, so it will be like L. Final, this will reach here, so your minimum workspace will be L. The minimum workspace will be L. The number of solutions will be so and effector position. So and effector position will be that will be your number. So we can see here in workspace 1, 3L, one singular point only. This is a singular point because this cannot go beyond it. So this is a limit at which it will go. So it cannot do anything beyond that, and so it will like unless you rotate this about this, it will go in this direction, but it will, beyond that it will not go anywhere. So this is a 3L. L1 plus L2, L3 is a one singular point. So if L equal to L, so if you see, if norm of P, so if you use L, so now if you fold all these things together, this will be your end effector here. So this will be your workspace now. And it is nothing but L. So infinite solutions with 3 singular points. So there will be infinite solutions. Okay, because what will happen is like, if why it is infinite solution is, this will move in this way. Right? If we move this also, okay, then what will happen is it will move inside. So it's like it is having an infinite solutions with 3 singular points. Okay, why 3 singular points? Because one will be here, another will be here too. One will be here folded, another will be here. Okay, these are 3. So one joint is here, another joint is here, and this is a global, right? You can see here this is 1. So you can see one singular point, second singular point, third singular point. Okay, so these are like, so you can see here these are like infinite regular solutions. So this is like here in this phase, this is the maximum limit of this link. This is the maximum limit of this link, and this is the maximum limit of this link. So now the workspace also depends on tool frame transformation, because it is usually a tool tip that is discussed when we speak about reachable point in a space. So now this is a reachable point. So when the given a goal frame G, corresponding list frame W is calculated, and then we ask, does it does this desired position and orientation of W lie in the workspace? Now we can see a planar arm with 3 revolute joints has a large dexterous workspace in a plane. So you can see a large dexterous, you can see here space. Because any position in the interior of the workspace can be reached with any orientation. So this is the last, because this, if you rotate here, it will reach here. If you rotate here, it will reach here. So it has large amount of dexterous area. The lower dashed line indicate a second position configuration. So you can see here, this is second position, first position, and the second position of that. Fact that the manipulator has multiple solutions can cause problems because yeah, so here the fact that a manipulator has multiple solutions can cause problems because the system has to be able to choose one. A very reasonable choice would be the closest solution. So you can see here the closest solutions will be there, which is closest to your works, whatever the work you have to do. Let us say you have to pick a point here. So whatever the closest point is that you have to select accordingly. For example, if the manipulator is at the point A, and we want to move to point B, a good choice would be the one that minimizes the amount of that each joint is required to move. So there is a minimization problem. So I'll give you one problem also of minimization. How this θ1 can be minimized to reach from one place to another. Okay, so you have to solve. You can solve this by different techniques. Whatever they have solved is by calculus of variation. And at undergraduate level, I don't expect you to learn calculus of variation.